Okay, so let's start again and look at some sort of different payment structure. Let's say we're starting at time 0, and over the next 6 years, or 6 periods, we're going to receive a certain payment. So right now we're not going to receive anything, but in the first year we'll just receive $1 as per normal. The next year we'll add on another $1. And the next year add on another one, and so on. And as you can see, it's following a pattern where each year or period it's going up by another $1. So how do we find the present value for something like this? Well, the present value is going to be equal. We're going to have to discount all of these back, of course, the number of years. So we'll discount that back 1 year. The 2 will go back 2 years. The 3 will go back 3 years. And so on. 5v5 and then 6v6. Okay, so how do we find a neat little formula that's going to take care of all of this? Especially if we were going to say multiply all of these by 50 or something and say it's going to go up by 50 each year, it's something you may not want to be dealing with. So in fact, we want to be able to put the 50 on the outside and find out what kind of formula we can put there. Okay, so let's have a look. Let's call this equation 1, and then let's multiply it by v, as we did in the previous videos. And we'll get our v present value plus v squared plus 2v cubed. So now it's really being like nv to the power of n plus 1 kind of thing going over here, plus 5v6 and plus 6v7. Okay, now as you can see, things don't really cancel out as easily as they did before, but there is a bit of a pattern still going on. So let's do equation 1 minus equation 2, as we did in the previous ones, and we can even, let's just factorize earlier, just because we've done it so many times. 1 minus v is going to be equal to. So let's start with the thing with the highest power, the term with the highest power. If we're going to be minusing the second equation, so let's start by minusing 6v to the 7. Okay, and now we'll go like this. So we're going to see plus 6v to the 6 minus 5v to the 6. And what does that become? Well, that becomes just v to the 6. So I'll write that in there. Plus v to the 6th. And we'll say, so we've taken care of that and that. I'll just cross them, we've taken care of that bit as well. Now we've got 5v to the 5 plus 4v to the 4. Oh, actually minus 4v to the 4. So we've got 5v5 minus 4v5. Sorry, I said 4 before. So that bit over there is just going to be v5. So they're gone, and that's going to happen there. 4v4 minus 3v4 is just v4. So they're gone. v3, v2, like that. And the first equation is positive, so this is just plus v. Okay, so we're getting somewhere. And we can still keep this bit, the present value of 1 minus v, which can also be called d, whatever you want. We'll see what we want to call it later. So, let's take out v as a common factor over here, even though we can already identify that this bit over here is looking to be just a regular annuity, which it can be, but it just makes the equation a little less neat than we want it to be. So, let's just take out the factor v, and we'll go like that, and we'll still keep everything the way it was. So we're going to say minus 6v6 plus all the others. Well, actually, yeah, that's exactly right. So that's still a v, and that's 1. Okay, so this has gone down, they've each gone down by 1. Yeah, perfect. And we've still got this bit. 1 minus, I'm getting ahead of myself and writing before I'm thinking. Okay, so we've got here this bit. Now, this looks a bit familiar. This looks like NVN, which I think if you look at the increasing annuity formula, it's there. This bit over here is, unlike this bit, is an annuity due formula with N being equal to 6 because there are 6 different payments. So, in fact, I think what we can do here is we can just write this a little differently and say that can be A6U minus 6V6, that's all in brackets. We have a V there. Let's divide everything by 1 minus V. And then we've still got our present value is here, so we've just divided everything by 1 minus V. And now all there is to do is find out present value equals, we'll keep that bit there, sorry that's a 6 there, minus 6V6, and I think we worked out in the previous video that V divided by 1 minus V is actually equal to I. And you can see in the previous video how we worked that out. And so here is the formula. And that's how we get that increasing annuity formula. So in fact, sorry, I've circled that bit. Let's put it in a different notation. That when the payments are made at the end of the year on an increasing annuity formula, it actually equals to an annuity due, where the payments are made at the start of each year, less NVN 6V6 divided by I. And that's it. That's how it's worked out. So hopefully that does put a bit of clarity on that formula, because I know it's probably one of the more complicated parts out of all the different annuities itself, but I think getting an idea of how they're derived and actually doing it yourself makes all the difference, because if you're sitting there in the exam, you can actually even derive the formula yourself, especially when they come up with one of those complicated questions saying, show how this is equal to something that's similar to it. Anyway, thanks for watching. This is an Actuary Dude video.